So we're going to look now at dividing a whole number by a single digit times the power of 10. Remember, now, if you haven't already watched our video on multiplying a whole number by a single digit times the power of 10, you might want to watch that first. Okay, now remember, a single digit times the power of 10 is something like, we're looking at positive powers of 10. So that would be something like a single digit like 800. So an 8 followed by zeros. Or something like 2 million. So a single digit just followed by zeros. Okay. And remember as well, we looked last time, see if we're multiplying by 10, it's going to move us up the place value scale. So it's going to move, times them by 10 would turn a unit into a 10, turn a 10 into 100, turn 100 into 1,000. Dividing does the opposite. So if I took 1,000 and divided it by 10, I'd get 100, moving down the place value. If I divide it by 10 again, 100 divided by 10 is 10. If I divide by 10 again, I'm going to go down the place. Oh, why am I writing 100? I divide by 10 again. Oops. I'm going to turn a 10 into a unit. And I could do like 2 steps in one. So if I divide by 10 and 10 again, that's the same as dividing by 100. That's going to move me 2 places down. If I divide by 10 3 times, that's the same as dividing by 1,000. Okay, so if I look at the place value here, dividing by 10 is going to shift every digit down 1 place in the place value system. So here I've got my units, tens, hundreds, thousands, 10,000s, and everything's shifting down. Okay, so that for 40,000 is going to move to 4,000. That 5,000 is going to move to 500. And then I'm going to have no tens, no units. So it's like I've shifted everything down a place. Now this only works for whole numbers, okay? It's like I'm knocking off a 0, okay? So I've got 3 zeros at the end of this number, and I've only got 2 at the end of this one. It's like I've knocked off a 0, okay? That's one way to think about it, okay? For this one, if I'm dividing by 10,000, okay, I'm moving it 1, 2, 3, 4 places smaller. So it's like I'm knocking off 1, 2, 3, 4 zeros. Now, this does not work for decimals. And if there weren't 4 zeros to get rid of, it wouldn't work either, okay? So this is giving me 2,800, but just, this method's easy, but take it with a pinch of salt, okay? It doesn't always work. If I didn't have 4 zeros to get rid of, it wouldn't have worked, okay? And if it was a decimal, it might not work, okay? Here is slightly different. I'm dividing by 500 instead of just 100. So like I did before, I'm going to split this into 2 steps. So this is going to be the same as dividing by 5 and then dividing by 100, okay? So I'm going to do my divide by 5 using the division algorithm here. Okay, and then I'll divide by 100. Might be easier to divide by 100 first. We'll do that for the next one, okay? Doesn't matter which way around you do it, really. Okay, so if I'm dividing by 5, I'm asking how many 5s go into 4? Well, no 5s go into a 4. 5's bigger than 4. Then I'm asking how many 5s go into 45? Well, that's 9. How many 5s go into 0? Well, 0, 0, 0. Okay, so now I've done that first bit. I've divided by 5. And now I need to divide by 100, so I'm making it 2 places smaller. That's going to be 90. My 9,000s are moving down to the hundreds, down to the tens, and I've got nothing else. Okay? So for this one, I've got 75,810,000, and I'm dividing by 3,000. Okay? So 8, 1, 0, 0, 0, 0. I'm going to divide by the 1,000 first here, and then divide by 3. Okay, so I'm going to move it 1, 2, 3 places smaller, getting 75,810, and then I'll divide it by 3. And I need to do a sum for that. 75810. How many 3's going to 7? 2 would give me 6, and then I've got 1 left over to make up to 7. How many 3's in 15? Well, that is 5. How many 3's going to an 8? 2 again makes 6. This time I've got 2 left over. How many 3's into 21? That's 7, goes exactly. How many 3's go into a 0? 0. So I've got 25,270 as my final answer there.